Hello everyone, Kenty Tiger here with Bengali Engineering and Play. We are continuing on in our new Space Engineers adventuring. This is kind of a satellite series, kind of. Um, I'm mostly doing this out of character, so we're really just building and playing. So rather than trying to stay in character, so one of the things I've left this run for a little while, built up some materials. I got the nanite control factories online, so now we have a combination in this base of not only the nanite control factories, but the build and repair system. So there's actually several different aspects. Um, the neat thing, um, like I said, one of the advantages of the nanite control factories over the build and repair system is that it has the ability to auto queue. So using the two systems in conjunction with one another is actually really incredible because they both determine broken things in the same way. And what I mean by broken things is unfinished things in the same ways. And so in this case, the nanite control factories actually determine, hey, this is what's incomplete, this is what I need, and it queues them. And then the build and repair system steals all those parts and builds. So the conjunction between the two actually is really incredible. So uh, within the limitations of the system, as it was getting more and more assemblers online, it was actually really fun because the nanite control factories were queuing everything. But the good news is because all the assemblers were working independent from one another, it actually queued up a lot of stuff really fast. So in the end, all of the construction on the base is now complete, um, and I'm just kind of left to continue on in the building process. So anyway, what I wanted to do is kind of show off what these nanite control factories look like, because these things are really expensive to build. Which so let me get down here close enough. Hopefully, there we go. So obviously you can see there's a very long laundry list of stuff that you need to work with here, and I find this to be realistic from the perspective of these guys are pretty powerful in what they can do, especially given the range and everything. So the fact that they are pricey in a lot of different ways, you can see it needs a lot of gravity generator components, it needs detector components, it needs interior plate, construction components, displays, computers, pretty much anything that you could possibly need, it needs, including superconductors. And you can see there it needs 1,200 superconductors for a single factory, and there's two of them here. So, needless to say, lots of time to get everything. The modules here, the reason why I left this open was just to show off the modules. So the nanite control factory itself is 3x3x3. This obviously sticks up above the plane here. So it's two above and one below. There's actually 5 different connectors on it. So conveyor ports. One is on the bottom center, which is actually the one that's in use. And then the ports on the side, which are at the cardinals, also conveyor ports, but can also be upgrade ports. So I use them as upgrade ports. In this case, you can have 12 upgrade modules per factory. I'm using all 12 slots. The only difference between these two in how they are upgraded, if I can find it, is I think this is it here. Let's see if I can zoom in far enough to see it. Projection. maybe it is on this other one. Anyway, there's a medical upgrade module available, and well, that one looks different. So that's probably the medical right there. Yep, and it says medical, and it's got the little heart with the bead on. So the neat thing about the medical module is that it can heal you, so you don't actually have to walk up to a medical bay and touch the tea. This thing can heal you from afar. So if you're within its range, which is 300 meters, then it will heal you by way of nanites. So it's actually kind of a cool thing. So this one module, I think there's 3 streams total out of that, is the differential between the 2 of them. Otherwise, they're identical. There's speed modules on here. There's a projection module, couple projections, and deconstruction. So what I did was put a variety of each of the types of modules for the sake of flexibility, is really what I wanted. Now, the other thing, which is also true of the build and repair system, these guys are really power hungry. So that's one of the other aspects that may be a challenge. Anyway, what I wanted to accomplish here was just to kind of display what these guys look like. And I normally encase these in, see if it'll actually do it. Put corner pieces in. Oh, I need steel plate. Production. So we have 2 goals here. The largest scale of the goal is to get the cover plates down over here. So what I'm going to do is put block in the corners, and then come back and put on plate. So really, that's just a catwalk plate, because I tend to use catwalk plate quite a bit in building, just to cover things up. So no real construction components, of course. Right, here's the advantage of having a completely interconnected system. So I'm looking for construction components, and can't find any anywhere. Do we not have any construction? There we go. Really not have any. Wow. Alright, production. Medical components. So this is just to get things going. Okay, so I pulled in construction components, which is what I really needed here. Steel plate. I wonder why they're not building. It's really strange. Alright, catwalk. So what I like to do is use the steel catwalk plates not only as a decorative measure, but as a you can actually seal up holes in the decks with it. So as we're demonstrating here, this kind of a thing. Now I'm confused on why the build and prepare. So the nanites are what launched here to do all these things. So the colors of the nanites actually mean something, and they're flashing this cayenne color, or sorry, this magenta color, and if I remember right, that means it does not have the materials it needs to do what it does. So we may have some issues. But so the goal here, as I was saying, is to put plating on the ground to cover up holes and such. So that's really what we're doing here in this case. And I don't know if I turned build and repair system off. What I don't know what I did here, but something happened. Everything, so I'm not sure what is going on here. So repair system, looking for anything that's incomplete. Everything is there. So just like with the build and repair system, if you go in here and do a K, it can tell you possible construction targets 26, and it will tell you what it's missing. So it needs 81 steel plate and 427 metal grid. But what I don't understand is why is it not queuing. So use assemblers. Let me go ahead and check my production assemblers. Cooperative mode. Off. On. Toggle block off. So I really don't know what's going on there. For some reason, so we need metal grid. Back in here. Metal grid. Steel plate. Could have keyed it from right there. I'm being stupid. Production. Construction components. Assembler 2. So there's steel plate think metal grid. I bet we're out of either cobalt. Probably cobalt is what we're out of here. Nope. It does say we got it. Alright. So the build and repair system was functioning. It was just waiting on those sorts of things, and for whatever reason, the nanite control factories were not queuing. Okay, so this one turned green again, which is good. It means it's in standby mode with power, which is good. So basically what I wanted to accomplish here, and why I did not do this on screen, was to kind of demonstrate a way to close up the floor if you're working where you have issues on a floor. So the goal is to create this room, and this room is obviously very large, but to actually seal this room. So what I want to do, and the way to look here, so main space, pressurization status. So if we look here, the main space, the air vent main space is actually the air vents that are in the overhead here, and it says they are at 100%. Okay, so that means that they are detecting that the place is sealed, and that everything is good. Now the outer draw-in are always going to be leaking because they're outside. They're set to pull in, so they will always they will always be leaking because they're not in a sealed environment. Effectively what we've done here, now that we've got the plating on the floor and the in fact glass over the top of the build and repair systems, then we have in this space turned green, which you can see here. So we have indeed gone over to green. So this is now a pressurized space, even though we are on a planet. So this is a completely pressurized and sealed space, which is what I wanted. Alright, so we have accomplished quite a bit already. The only thing that we actually have left to do is to put in our sorting system. Conventionally, I know this is doesn't necessarily make sense in terms of a ship. This is base, but I'm looking at the entrance, and let's just pretend for a moment that this is a ship of some kind. The entrance, in this case entrance and exit, is the bow of the ship. Okay, so let's just pretend. That means everything to my left is the port side, everything to my right is the starboard side. So if we're lettering or labeling with naval shipboard life in mind, everything to the right is odd numbers, everything to the left is even numbers. I know that sounds really silly because in a left to right world it should be the other way around, right? But for whatever reason, and actually it does make sense if you consider that 0, which is center line, is considered to be an even number. Okay, so we go left starting at 0. Okay, so anyway, for what that's worth. This over here, even though I have not necessarily followed this convention, this is going to be, I want to name this. So this actually is container, and it's pull in storage 01. Okay, and we're going to do, so what that was a backspace shift home, which highlights everything, and then a control C because I want to copy that. Go back in because I can do that all from here. So container, right? This is the container on the other side. How do I know that? Because it's the only other container that's not named and put somewhere yet. So get my cursor into the box, do a Control A to highlight everything, a Control V to paste what I wanted, and this is O2. So side 1 and side 2, which actually, if I were doing like we just discussed, it would actually be side 2 and side 1. All right, I've got my sorters here, and I'm going to go to those sorters specifically. So I'm on side 2 because it's an even number. And I mentioned these control panels. So this is sorter. So we're just going to call that a sorter, and this is pull in number 2. Okay, so because there's 2 of these particular sorters, then we do the same thing on this one here. So it's called sorter, pull in, and in this case number 1. Now both of these are configured the same. So here's how we configure. I want to pull in everything. Okay, and so to do that we do a drain all, which is going to pull in everything. Filter mode blacklist. In other words, don't pull this through. So if we kind of let that logic float in on itself, don't pull this through, active filters nothing. So don't pull nothing. If we conceptualize that now as a double negative, don't pull nothing is pull everything. Okay, so I know the filters, that particular concept right there can be a little bit challenging to deal with, but bear with me, that really is the reality of things. So blacklist nothing is actually a pull everything. So we were on sorter number 1. We're going to do the same thing on sorter number 2. Drain all. Sorry, go back up here. Drain all, blacklist nothing. Okay, so blacklist nothing, allow everything. Okay, so both of those sorters actually configured the exact same way, which is what I wanted. Now, if I were to be intelligent, then one of the things I would do is actually do an interconnector. And the reason why an interconnector may be a good idea is how fast can I move material in and out of these things? That could be a challenge. So the problem is these systems actually are completely independent from one another, which may or may not be a problem. So one of the things that I could do here, and I think I will, is go up into the overhead and over the top. So what we need to do here is we'll bring this up. We actually are going to have to go to our grind color. So there's a grind, and then I'm not sure where that's going to be just yet. So let me go over here and grind this. We'll change colors. We're doing red in this case still. We are going to put that particular thing on there, and up, which now, whoa, darn. Which now we know where that is, so we know that's there. I'm going to go ahead and change to the grind color, and then click, okay, which is going to put my piece there. Alright, we'll do the same combination of stuff over here. So we need to get back to our painted color. We're going to put a conveyor junction here, and then 1 and 2. We're going to change colors to our grind color so we can go through the overhead, which is like this. change back to our red, and then change a little bit here. So ultimately, we're going to put a conveyor junction in and a piece there. So roll for conveyor junction and that. All right, now the purpose for this, and I could have done this inside. The reason why I didn't do it inside is because I really don't want anything going in the overhead, but as in at the ceiling. Okay, so I have room outside. Obviously, it's in the rock, but I have room out there. So there's no reason to do anything else. So I'm gonna shift back over into my spectator. I'm gonna go up and over the top, and then I'm gonna figure out where those particular pieces just came in. So they are over here. All right, so sorry. Things don't work, you make them work. All right, so as long as I'm doing maybe that way, see if this will work. Currently set up really slowly for some reason. So we're back to this mysterious thing not doing what it was. Oh man. No, didn't actually want to do that, but oops. Alright, we'll fix that. That was my oops. So the first thing I need to do is fix that, then fix the overhead here. Alright. That was an oops. To change colors again, we are needing to put in elbows. And there we go. All right, so what did we accomplish here? Go ahead and 0 and speed up a little. All right. So this was our interconnector here that basically connects side to side. And the reason why this is important is that if something is queued up like in let me back up. I've got, unfortunately, 2 independent sorters. So they could have pulled material out. Let's say on side 2, I have all of my, so I've pulled in a bunch of ore on both sides, so side 1 and side 2, but my refineries on the side 2 are full. But I have ore sitting there. The refineries on side 1 finish what they're doing and are sitting idle. And they're sitting idle because there's no way to get the material from the one side over to the other side. So this interconnector on the pull side is what's going to allow for me to take that material and do something with it. Okay, so that's what this interconnector was really all about. Now, I'm not sure why. Oh, actually, I am, because they're not built yet. Why they're not built, but all right. So control, get back into my character here, and the reason is these are not built yet. Again, I don't, for whatever reason, the nanite control factories are not queuing. They queued before, but they are not now. So let me go ahead and turn this off. Space Master, get back into the correct mode here. So the good news is you can actually talk to any of the build and repair systems, provided you can get there, and see what it is missing. So let's go ahead and build and repair system. Pick one, anyone. It's waiting for motors. Okay, let's see if that's consistent all over the place. Yes, indeed it is. All right, so K, production. Okay, so we're waiting on, apparently we are out of cobalt. So let's move motors up to the very front. And of course, if it's waiting on cobalt and I'm out of cobalt, then that could be a problem. Got a lot of cobalt there. Got platinum, gold and silver. Rather, silver gold. Alright, so this could be another argument about the game being too stupid for itself. So container. In this case, it's full. So the assembler actually will stop working because it's full. It can't move stuff out. So platinum. So there you see, as I move everything out, then it pulls back in what it needs and it starts doing what it does. Unfortunately. This one is the same. So, wow. Production. So this one's filled up itself. Silicon. As long as it's doing what it needs to do, then I guess I don't really care. But all right, let's see. Yep, that finished, and this finished. All right, so now what we effectively have is a twin system. So a system that will indeed pull in two different directions and store in two different containers, but now effectively, because of this overhead loop, these two containers are connected together, which is exactly what I wanted. So we are pulling materials in. So basically our ore is going to be pulled through and go into here. Okay, and this is at the behest of the refineries. So the refineries actually are only going to pull in materials that they can do something with. So normally I like to do sorting, but that's not necessarily, you know, a mandatory need. So here's what I'm going to do. I'm looking for scrap metal. And what I want to do is pull all this scrap metal in, and in the interim, I guess I'll keep those. So my refineries are live. They are doing what they do. So what I want to do here in this case is take this scrap metal and put it through here. Now I can't get to that from there. That's that connector on the outer, which is only connected to the supply grid. So that this is behaving normally. So one of the things you saw here was that I dumped that scrap metal. A refinery is going to take scrap metal and turn it back into iron ingots, and all of those disappeared. Okay, so what I want to do here is let's go ahead and go back into inventory and look at our refinery, and you see refinery number 1 actually took all that scrap metal and turned it back into iron. That may be the only one. Yeah, so just number 1 picked that up. So that's actually, you know, a really good thing. So what do we need to do here? Well, we need to take materials and move them in particular directions. So
energy critical.
Let's let me go off screen for half a second and pull in all right. Let's talk about this for a minute. And at the very beginning, which is really, say, at the bottom of the trash heap, I did a tutorial about sorting, and I'm actually going to redo that video because I did not yet have my sound system all set up correctly, so you can't hear a damn thing I'm saying. So I apologize for that for those of you who have been really, really frustrated. So let's talk about this really, really busy diagram here for a moment. This is your This is your sorter. This is your sorting system. So if we look over here, and I know it's really hard to see the reticle, the arrow, this is the pull-in system. So this is the red system. We go into the sorter that pulls in everything. So blacklist none, we pull in everything, and we then go into unsorted storage. Now, unsorted storage and temporary storage are basically the same thing. So if we think about this as in terms of these are the two containers that I have sitting there. Now there's two different sorters here. One of them is pulling gravel, ore, and stone, and the other is pulling ingots and ice. Whitelist, ice, ingots, drain all on. Okay, so this is an ore blocker, so everything goes into here, goes into storage, then comes over here into refining. So we don't actually have this sorter. So the idea here was that this would allow the pulling of just ingots and ice back through and then out into this. So conceptually, this is exactly what we want to do. So we have to have some way of getting this ice, and remember, ice is ore. So if you have a sorter set up for ore, it will pull through ice. Now, your refinery is going to do absolutely nothing with it. It won't even take it inside. It won't let you put it inside. But you need to have some way to get that ice out of there. So this ice and ingots is that way, that mechanism to pull this ice and stuff back out of your refining section and then throw it in here. So this is a little more complicated. So we have a storage section, a dedicated storage that basically pulls ore, including ice, stone, and gravel. Okay, stone and gravel. Gravel, of course, is processed, but in this case, we're using an extractor, which will take that gravel, extract those, minute components out of there, microscopic components, and then be able to store it. So gravel. Okay, so stone. The refineries turn that into gravel, and then the extractors can actually do something with it. So this sorter here was to pull the gravel through, dump it into gravel storage, and then the extractors would do whatever they could with it. This minute, these microscopic particles of all these different elements, which then will be pulled back into the refining process. Once the refineries turn them into ingots, we pull the ice and the ingots back into this temporary storage here. And then from that temporary storage, we actually sort according to these main things. So in this case, sorters 4, 5, 6, and 7 are dedicated. So in this case, we're pulling ice and ingots through. We're pulling components, which is to say all these components that we're using. And then our miscellaneous tools, so our hand tools, the bottles, that sort of thing, and then ammo. So the idea here is that we can pull in anything, but not everything is going to need refining. We're going to pull in components. We're going to pull in hand tools. What do we do with those? Well, that's what these sorters are all about. It pulls them through and then dumps them. So we put them into storage assemblies, and much like we did here, we've actually completed this section. So I have my storage, even though I'm not independently naming it. Then we're going into the assemblers. There's two different assemblers, one on each side. Because everything is interconnected overhead, interconnected, then I have actually 6 storage containers. So I have 6 cargo containers, those big cargo containers. And then I have assembly arrays on both sides, so 5 assemblers on each side. And then those all interconnect back into that supply, that green system. What else are we doing here? So this portion is only partially done. I don't have extractors here. I'm probably not going to put extractors in. just because they are non-standard. I do have one that's embedded into my personal mod, so we could use them, but I really don't want to, because that's I'm trying to keep this relatively vanilla. Not entirely, but I don't want to go completely outside the universe. So in our case, we do not have the sorter S3, we do not have the gravel storage, nor do we have the ability to do the extraction. So we really just have the refining. I don't have an independent storage of ore and stone. It is pulling it out of this storage. So really what I need to do from this storage is have a way to pull all these different items through. And I can actually do this with one sorter. That's not a problem. And we're going to do this in a kind of a bizarre way, because of the way sorters work. And this is another kind of a game bug and a way to get around the game bug. You notice these headers. So in this case, these headers, that assembly comes off of this header. Why did I do that? In this case, on the pull side, it doesn't matter. If I were to be pushing stuff in here from a sorter, then, for example, here, even though this container is connected to this container via this header on this side, this sorter will only push into this container. If this container fills up, this sorter will stop working, even though I have a direct connection on with this guy, with this guy, with this guy. Okay? It will only push into a directly connected container. Okay? So what I'm going to do is build headers and then plug my sorter into the header, which means if this one fills up, this one is still directly connected, so it will start pushing in here and here and here. Okay? So anyway, we're going to go back and forth on this, but I just want to show you where this is. In this case, we do not have a fuel ice side, so I do not have that blue independent side, purposefully so. All right, so this is just the overview of sorting, and eventually in one of my series I will come back, because I want to redo that sorting tutorial, because I think sorting is confusing to a lot of people, so I wanted to do I want to redo that tutorial. All right, so we'll shove that off the screen. Get back to the real game here. All right, so effectively we need a sorter that is going to pull material out of these and back through. So what I'm going to do is I'm going to put a sorter up here on the wall, up here on the bulkhead. So 7. I'm going to paint that an intermediate color. You know what? I think we'll just go ahead and paint it green, because that's really ultimately where it's going to go. All right. I'm going to put this the right way. I want my controller out here. Okay. And we're going to go ahead and put that right there. It's 1 square up from the refinery, so it's not touching, but it's there. And here's what we're going to do. Ultimately, that is going to pull out of these 2 containers. Remember, this one goes up in the overhead and back down. So I have access to both of these containers via this. So here's what we're going to do. We're going to come out of the back, and we're going to come out in green, of all things. We're going to go straight up. We're going to do this, and then we're going to do another elbow, and we're going to come straight into this guy. The question is, what am I missing here?
No energy. energy.
So we have a bazillion girders. We have some steel plate. What are we missing here? Superconductors. We have no superconductor. Interior plate with very little. Huh. I'm not sure why. So let's have a look. We're gonna pull out our welder. We're gonna find out what's missing. Computers. Computers. We're missing computers. So let's queue up some computers. So we're gonna do a K to get into production. We are at assembler, and let's queue up 1,000 computers. There we go. And maybe queue up displays and bulletproof glass. All right. And there we go. Okay, so this is let's go ahead and name this. So this is our finished product sorter, right? Finished items. Okay. Like our other things, we want to drain all, but I'm not going to do that yet. We are going to whitelist this because we want to specifically tell it what we're pulling through. We're going to pull through ammo. We're going to pull through components. We're going to pull through hand tools, and we're going to pull through ingots. Okay? Now, why am I pulling through ingots? Because this is interconnected right here backwards to these refineries. So the refineries are going to be pulling material out of these containers into the refineries, and then they're going to sit. Okay, so rather than creating another manifold on this side where I'm pulling just ingots out, I'm going to do that backwards through here. Okay, so this guy is going to pull stuff out through here. Likewise, that same sorter is going to yank stuff out backwards through here, up in this overhead, and through here and out. Okay, so I'm actually pulling stuff from both sides via this one sorter. Now we're going to duplicate this same thing on the other side, just for efficiency. That way, if something blows up on this side of the base, I haven't completely killed my way of working. So really, I need to call this O2. Okay, so let's look carefully again. We're whitelisting. We're bringing through ammo, components, hand tools, ingots, and in fact, I want to bring through this thing called ice. Now, interestingly enough, hydrogen bottles and oxygen bottles do belong to hand tools, but sometimes, they may have fixed this, I couldn't actually bring anything through. Now, here's the other caveat to that. If you have a ship that has bottles in inventory, even though your sorter is a drain all, it will not pull bottles. This is actually a good thing, because you need those bottles in your inventory. So if you put them in a ship, it will very purposefully not pull those out, because it really kind of screws you when it does. Because, okay, I have all these bottles in here, and oops, they're gone. And all of a sudden you didn't think about that. Yeah, I've hooked up to, my refinery 20 times, and it's pulled all this stuff in, and I didn't even think, that it's pulled all my bottles out. So that's one kind of neat thing about the sorters. There are restrictions. I wish there was a checkbox that said pull bottles, don't pull bottles, because sometimes you want it to. By default, obviously you don't, but anyway. So that's one of the interesting things. So what I'm doing is, instead of using 4 different sorters to pull all this through, like you saw in the diagram, let me, oh, of course not. like we saw in the diagram. So these 4 sorters over here, rather than doing 4, I'm actually doing everything on the 1 sorter. So we're doing it all there. So the only thing that I could add if I really wanted to was the hydrogen bottle and the oxygen bottle. So having done that, let's go ahead and build that on this other side. So green up to basically sitting right above that that first refinery. So let's go ahead and do the same thing over here. That's on number 2. That's about positioned correctly. I'm the correct color. And then it's just a matter of actually plumbing this in. So we're going to do the elbow first, which is going to connect onto this conveyor, pointing up. We want this. We need an elbow this way. And then 3. Interior plate. Oh, okay, that makes sense because this is a Kenti sorter. There was a lot of things I tried to balance out, and that was actually one of them that I tried to, because these sorters work so much more efficiently than the others. So interior plate, right? Here, this is going to be called, let's go ahead and scroll down the list so we can see. Let me turn that off so we can get to it. So we have the containers, we have the sorter, finished items 01 and 02. So in this case, this is finished items 01. Okay. So remember that we whitelisted. And as we scroll down here, we're going to put in so ammo, components, hand tools, ingots, and ice. Right? So the 5 things, and comparatively, we'll go ahead and look over here. Okay, so ammo, components, hand tools, ingots, ice. Drain all. Drain all. Okay. So, whitelist, blah, blah, blah. This one should say the same. Whitelist, blah, 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 and drain all. So, what this ultimately is going to do is create a mechanism where we pull in all of these items that are already finished from our pull-in system, because there's no processing required. Just pull them right straight across and dump them into storage, right? So that's exactly what we want to do. And to do that, I'm going to conveniently, I'm going to connect onto here. You know what? No, I'm not. And here's why I'm not. So ideally, and maybe we will go ahead and do this, is to create an interim header. I'm going to use a really dark color. Oh, that doesn't look a whole lot different. Still looks greenish. But here's the goal. This is an interim sort. And what I just want to differentiate it is so it looks different from these guys. And I guess I could actually take that to an extreme and just make it white, because white really isn't white. So let's do the same thing again. Paste, paste. Top here. It's slightly green for some reason. Alright. And we'll do the same thing over here. This corner piece. This. Alright. And here's what we want to do. We want to create this is going to look a little bit silly, but I want to do it this way. Alright, so this is going to look a little bit silly, but there's a reason for this one. And we're going to do the same thing on this side. So we put a junction, and then actually this. Sorry, I know bouncing back and forth is you're wondering what the hell is he doing. Okay, so let me go ahead and finish this side. Okay, so what have I done here? I've basically created a header because I want this sorter to be able to push everything in to each one of these things independently. So I need to get above this thing. Oh darn. Okay, and face this down. Change to conveyor junction, which is actually conveyor tube. Alright, so here's what we have done. We made a connection point out from this, and we created a header assembly here, so that sorter is now directly connected onto all three of these things. So now that sorter is directly connected to all three of these. Therefore, this guy cannot get plugged up if that gets full. It will just dump into the next one because it's directly connected. We're going to do the same thing on this side. So just like the other side, we want to directly connect everything. There's that one. That one. So now we have a directly connected header over all that. Now, here's the one thing that is a little bit quirky here, and we could fix this. This thing not only goes up and interconnects up, but also connects side to side. So if we really were being intelligent, we would actually connect this into there, because then that would push directly across, and then all six, which is to say both of them on both sides, are now interconnected to everything. They're directly connected. So having said that, let's go ahead and do that. And then, because I'm slightly over on time, then we will end the video there. So this shall not take long. Okay, so we were picking white. The first thing we need to do is well, we can put that in. We need a junction. We need an elbow to go up, and then there we go. So, if you see a bit of redundancy here and are wondering what the hell, then that's fine. So what we could actually do, and I like this little redundant thing here, but just because of what it is, I'm going to go ahead and get rid of these pieces because they're completely unnecessary, and at the same time we're going to recolor just a little bit. So that one's green, that one's green, that one's green, that one green, that one green, and in fact that one green. So looks a little strange, yes. So, painted, 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 and painted. Then, green to get our color there. We're going to paint that one. We're going to put a junction in right here. And we're going to come out of this one. Now, technically these headers are completely interconnected from side to side. So each of the sorters now can push independently from one another into all 6 containers. So we have successfully interconnected using these overhead mechanisms. So good thing. The only downside is that if we're pushing from side to side, it could actually fill up inventories of things in between. So it could push into these build and repair systems. Alright, so I think we've accomplished everything that I had intended to accomplish. I got most of the sorting mechanism done. There's a couple things left, namely what I want to do is have a methodology by which we can take unfinished products that got stuffed into the main sorter, which is really to say raw materials. So if raw materials get stuffed into the main storage area, how do we get those backwards into the refining portion and turn those back in. That's actually pretty easy. So, having said that, we will go ahead and stop the video here. This is Kenty Tiger signing off. Thank you for watching, and we will see you next time.